Hello everyone, I'm going to talk about 230 Kth smallest elements in a binary search tree. The question is, given the root of a binary search tree and an integer k, return the k smallest value. Index of all the values of node in the tree. Okay, so the root is like this: 3, 1, 4, and none. This one is 2. Okay, this just means the tree. Okay, so how could we solve this problem? Because this is binary search tree, so it has a specific order in the, and it's kind of like a in order. So which means, for example, this 3 and the left part is always the smaller than this one if the current 3 is the root, and for the right part 4 is always larger than the current root. So it follow. This is the binary search tree. Okay, so find the k smallest element. So we can use keep searching for this one, and every time we go to the left part, we always can, for example, for here 5, right? So we go to this one. And finally, we go to the left part, the left first. And then every time we go to here, we have the a global k to tracking current thing. We need to find current 3, right? So we need to go to the left part, and every time for here k is 3, and go to the left, and k go to the left. It will touch here and return back. And every time when we return back k minus 1, so it's where 3 here, it's 1 minus 1 is going to 2 and go to this level. 2 is coming, right? It's no, for here is go to none, and none it will return back. For here k minus 1 is equal to 2, and 2 keep return back. K is equal to 1 and return back. For here k is equal to 0 now, which means we find the k smallest, then we return current root. So that's just the idea about this one, is to kind of use the DFS to do this problem. Let's write the code first, then we can better understand this. So for here, I want a global k and also private global readout. So let's see. This k is equal to k. This k equal to k. And then we have the DFS root, and then return the result. So for here is DFS, we do the keep going to the left part first. If the root is equal to none, so which means we should return we just return back. For here is none, return, yeah. And then we can do something is DFS left and then for here k should equal to -1. Every time return here, right? Which means this one should be the minus 1. If the k is equal to 0, we can return the result. Result is equal to the root value, and return it. This should be k equal to 0. And then if not, we should go to the right part. Let's see. Yep. And for the time complexity, we at least to check every node. So the time complex will be the check every node, and for the space for here, we actually for the level about this one. So it will like this. And also we can treat this as like a same, it's constant numbers here. We can treat like a high level, because the worst is the tree only have all the nodes just in the one line. That is the worst case. And let's see whether it encounters some problems. Yeah, it works now. So we go back and think about this again. So k is equal to 1, right? And take this example, k is equal to 3. So we have the global k, and we store the result. Now we go to run the DFS. This is the base case. So we only touch the last one, it will go through this one. So we can go through from this one, like 5, right? And go to the root left. And then it will go to try again to run this root. And it will also encounter this to check. If not, then keep going to the root left, root left, root left, until you touch this one. And then this also will call the root left. But what happened is here root equal to none, right? It will return back, which means it will return at here. And for here, k need to minus 1. So it will encounter 2 here. And then it will keep 2 here. Right, so and go to the right. And for the right part here, the root is none, so it will return. And keep return back to the 2 this here. And k minus 1. For now is 2, k is original is 2, 2 minus 1 is equal to 1. And keep return back for this level here. And this level k minus 1, then for here we encounter k is equal to 0. So which means the result should be the root value here. Then we can return back for the 3 here. Just return back to finish the everything. And which means the DFS is finished. Then we can return the result. This is the whole idea about this one. Yeah, thank you.